Good evening and thanks for coming. So I'm going to talk about records which are classes, but which are constant classes, but it has much more stuff inside that. And it's supposed to play a larger role in things that are going to come, that's in the pattern matching and others, pattern matching especially. I'm Manoj. I work with IBM. I developed the Java compiler in the Java development tools and with the compiler for Eclipse. I mean, I means our team, Stefan, then a lot of others, Jay and Cleon, a lot of others work for Eclipse Java development tools. So what I'm going to talk about is what we have implemented already, and this has been implemented like a few releases back. There are not too many slides, but let's start with I don't know whether you are able to read this. Yeah, so this is I know it's a very pathetic way to start, but let me see. So the pandemic is over, and we decided that a lot of things we don't require. So our protagonist, Dave, he says, okay, I have a lot of shirts, I have a lot of shoes, I don't use any of them. I just want to give away the stuff which I don't use to charity. But how do I do that? I want to keep track of what I'm using. And whatever I use, I'll just put that into a wardrobe. And whatever is left, I'll just give away. So he decided that he will write a Java class for doing the same. Let's see what he did. Is it clear? Or do I need to increase the font? No. So he starts with something called class attire. And he says, okay, he just wants to keep track of two things. He just wants to keep track of, say, the shirts and the shoes. These are just strings. And then he says these are these need to be these are finite classes, because he just want to make sure that if he has a white shirt, then he keeps only one white shirt. If it was one formal shoes, he keeps only one formal shoes. So he says, okay, he'll write a constructor for this, and see, writes a constructor for this, and he says that these are finite classes, so he will just write final fields. So he just adds the final fields to model what he has. Since these are final fields, he thought, okay, he should have some accessors also, and no getters, because you're going to set it in the constructor themselves or constructor itself, and that's what he got. So he is pretty impatient and he wants to see what he has written. He thought he'll write a string function. And he writes a string function. Then he starts a driver. So now he wants to model a wardrobe. So he says, okay, let me write a wardrobe. And he writes that's something wrong. And he models a very poor wardrobe. He has two attires, A and attire B, which are both the same, white, formal, white shirt, formal shoes. And he prints it out. So what do you think will be printed out? Sorry, this toString is not there. I gave away the stuff. Yeah. Okay, what do you think will be printed out? I know you're all Java experts, so stupid of me to ask that question. So, yeah, something which is totally useless from Dave's point of view. So he writes a toString function. And now he tries again. Works fine. So then he says, okay, I need one white shirt, one formal shoes. If I have one more white shirt and one more formal shoes, then I can throw away one. So he needs to do a equality. So he does an equality and sees whether A and B are equal, and what would you think the answer is? False, right? Yeah. And that's not what he wants, because for him these are constants. He wants a equality based on these two instance values. So he writes a equals function as well. Luckily, he had read our man Joshua's effective Java. Joshua's right, yeah. So he knows that he needs to write a hash code also. He needs to. So he writes that, and then we get a true. He just wanted to throw away things. He wanted to be minimalistic. And look at the amount of the code he has written. So much. So he calls the Java folks and asks, do you have something better? Can we do something better? And Java folks looked at the stuff and he said, okay, forget all this. And replace the entire stuff with just one line, that is records. And when you do that, you get the entire stuff what is written here automatically for you. Who does that? The compiler does it for you. So before we get into that part, let's see what let's just get into a little more detail of records. First thing, record is that's a new restricted identifier. How many of you are familiar with restricted identifiers? Okay, Stefan, you don't count. He coded, so there are, yeah, I see others saying that. So what restricted identifier is? This record can be used as a identifier somewhere else, say here, and that's fine. It's not a keyword, but what is restricted? I'm not sure whether Jorg is here. Yeah. Yeah. So he had asked me a question yesterday, can I use record? You cannot use record because restricted means that you cannot use that restricted identifier for a type. But you can use it for an identifier. But when it comes at a particular place, like in this case, then this becomes a kind of a reserved keyword. Not a reserved keyword, kind of a context-sensitive keyword. So the compiler will interpret this as a kind of a keyword and say that, okay, this is something like class, this is a record. Record is anyway a class, but it's a constant class. And this has, so if you look at, if you don't believe me, let's see, if I'll just print it out, it'll print out exactly what the attire, what it was printed earlier, and say, this will print out the true, just like what they wanted. So what is it? It's finally a constant class. It's simple. Records are simple data aggregate classes. And there are things associated with record. You cannot extend a record. Record is always final. So it is implicitly final, or you can add, say, final keyword to the record explicitly. Doesn't matter. Ultimately, the compiler will interpret it as a final class. So when we implement the language specification, we would also have to implement the errors associated with records. So I wanted to just touch upon that. Like when we looked at the language specification, we had something more than 30-40 errors for records. And all of these were implemented, and some of them are very common errors, which is applicable to classes. For example, you cannot have two duplicate modifiers. So it's, then you cannot have, say, abstract. You cannot have an abstract record. Why do you think you cannot have an abstract record? Yeah, it's final, right. Stupid question, right? Yeah, it's final. So you just cannot extend a record. So, and the seal hierarchy, etc., doesn't matter here because it's final. But does record extend something? Yes. Records implicitly extend not objects, but it extends something called Java lang.record. This is given by the JDK. Now, if you look at this record, you will see that some interesting thing you see here is all these equals, hash code, toString, they're all abstract. So who's providing this? Now compare with an object. I know all of you know about this, but these are provided by native hash codes, etc. But in this case, this is not provided. This is an abstract method, and we ourselves are not providing inside our record because it's just one line keyword. So we'll come to that. Who provides this? Before that, before we get into that, a little detail about the record is about what are these things? What are these things which look like parameters? I mean, they in fact, although they look like parameters, they behave like parameters also in many ways. It should have a type, it should have an identifier. Then you can also have a variable number of say ... something like the method parameters, variable additive parameter. It can also have annotations. There are record-specific annotations. We'll come to that. And what happens inside is internally it creates private final fields, accessors, just like Dave was creating earlier. Now watch out for some of these errors. You cannot have duplicate names, of course. Just like that will give you an error. Fair enough. Interestingly, you cannot even have toString, for example. Any guesses why we cannot? Sorry, this is toString. Yeah, essentially we would have the accesses. You define this inside, and when you define that inside, internally this will create an accessor. We'll see that in the disassemble code. So there will be a clash. We can have equals, of course, because the equals as a parameter and there is no problem with that. So now time to look at some as a disassemble code. Where is that disassemble code? See, let's put this and class this. I believe most of you must have looked at bytecode, or many of you are working on bytecode or disassemble code very much. So generally, audience is very well aware. But just to give the idea that here you can see that the compile code would say final record something. This record is in fact something derived from what our disassembler tells. There is no separate keyword or there is no separate bit in the VM which says it's a record. We kind of derive it looking at an attribute which we generate at a later point of time. And if I look at the Java P output, this is you can see that it says final class. It doesn't matter because finally records are classes. So let's see what else should I cover. Yeah. You can see that implicitly these have generated the private final fields here. These two are the final fields. Then you have the constructor which calls the super Java lang record here. Then it loads the shirt and shoes and it allocates the field. So these are private final fields. So the initialization has to happen in a constructor, and that's what's happening here. And we do have the accessors defined. Only accessors, because setters doesn't make sense, a final field. Shoes and then all the toString, hash code, etc. are defined. Now you can see that these are defined here, but if you really look at it, the code is not there. The code is, you must have seen the code of Lambda, right? So they're using the invoke dynamic stuff. where at the last end, you can see that there is something called a bootstrap method. So this is the particular bootstrap method, object methods.bootstrap. We will come to that. Just a quick thing. Now we pass these arguments to that, and we also pass what kind of a method to generate. So that's all what we do. That's all what we do in, say, toString. For example, we take this toString. Here you can see that we just pass, in the invoke dynamic, we just pass toString backward attire. And you go down to the bootstrap method in object methods. Here, like look at, I just want you to concentrate only on this thing, which says, I'm not sure whether somebody can read this, I'll just read it out. You should pass a method name. It says method name. The name of the method to generate must be one of the equals, hash code, and toString. So what's happening is inside this, it is finally the JDK that will do the hard stuff. I think I'm done with this attire class, and let's go back to the source code where we are more familiar with. Yeah, so we have constructors. Constructors themselves are like a little descriptive topic in records. That are compact constructors, canonical constructors. We'll just touch upon that a little later. But assume that we need to have constructors. And member declarations we can define just like classes. You can define methods, extra methods, not only accessors. We can define static fields, no issues. But can we define non-static fields? Does it make sense? Yeah, why do you think?
Because we would need to consider them in equals and equals.
Exactly. Yeah, right. So we do something that in record it will give us an error. So we say static int count, perfectly fine, but I remove static, gives an error. Not permitted because it doesn't participate in hash down and equals. And the records are not supposed to be used that way in the first place. Can we have abstract method declaration? You cannot, because there is nobody else. The bug stops here at the record. Going down to the components. So we saw that the components, when you define component, that gets translated to fields and accesses. And then it comes to the question of annotations. We can define annotation, a record annotation, and say I've just defined one record annotation. And it is a new target called record component. But if you want this target to be propagated to the methods, which is the accessors, or when you define the field, then you need to have the target of field and method. So let's say I'll just show that. I'll just copy this record annotation and say, was it here or was it? Yeah, I think it's here. Yeah. Oops, where did it go? Yeah, record class went. You can see that I've just kept the record annotation to be at runtime anyway. It doesn't matter. But this is just to show that if you look at the record annotation, it has field, method, and record component. And when you look at the attire, you can see that it is at you can see it in the field. You can even see it at the at this accessors, only for shirt. So that gets propagated. The compiler generates code to propagate to the appropriate places. And if I remove that. Say if I remove this method, I don't want it to be propagated to accessors. You can see that the accessor doesn't have the record annotation. Now there is one thing which we should keep in mind is this is about implicit generation by the compiler. At some point, we are also allowed to do our own, create our own accesses. Oh, what happened? Sorry. We are allowed to write our own accesses. In such a case, the propagation is not done. The compiler will not mess up with your explicit accesses. So just keep that in mind. Where are we? Yeah, instance methods are allowed. Instance variables are not allowed. Yeah, explicit implementation is allowed for accesses, but just that annotations will not be propagated. Now comes to the touchy subject of constructors. When you think about a class, you always think about a default constructor. So default constructor generally doesn't carry parameters, right? And records you cannot have as a default constructor because these are private final fields. Of course, if there is, you can have a record without parameters, yes, then these two cases kind of are identical. But otherwise, you cannot have. You need to have something called a canonical constructor, which follows the record components in terms of the type, the definition, etc. So it should be like attire, shirt, it's a string shoes. This canonical constructor can be done in two ways. One is the implicit declaration, essentially meaning that you don't have to declare. The compiler will declare it for you, which we have seen in the dot class generated code. Or you can even define it explicitly. In the explicit declaration also, you can do it in two ways. You can say you can do it like a normal constructor, or you can just that's a compact constructor, where we just omit the parameters. But what happened to the shirt assignment, shoes assignment, etc.? Let's look at the attire class and see what do we have. That's there. You can see that it's still there. So the compiler, if you write a compact constructor, the compiler will implicitly add the assignment to the private final fields, and the parameters it will be assuming the same variable name. I just want to say, if one more point to note is that this is an error. If I explicitly assign, this is not allowed in compact constructor. So idea of using a compact constructor is a compact constructor, like a lot of things, are implicit. So you use compact constructor if you want to, say, normalize some values, or you want to say that do some error checking. Then you do all the stuff at the end, at the last after the last statement, after the last explicit statement, the compiler will add this assignment to the fields. Okay, so yeah, so that's all about it, and I'll just briefly touch upon, go back to this and hardly to another 3 slides. So you have these records, and where will they be used? They will be used in, I'm sure some of you attended the pattern matching talk, but the records would finally get into record patterns that are previewed in Java 19, or something like this. For example, if O instance of point int x int y, that's a record, and then you extract out x and y out of the records. Yeah, there's just a slide totally borrowed from the earlier presentation, where it just checks the applicability test of records and extracts the variables x and y, and it also initializes the x and y too. Because records are constant classes, right? It's a data class finally. So you would have initialize point with say 0.01. So at this point you would get x plus y as 0 plus 1, 1, if it matches. And gets propagated into the pattern switches if you're, and if you're, okay, I think I'll just leave this part. This is all about sealed interfaces if you've used. Just want to finish off saying that this is a JEP 405 is your is the reference for this talk, and okay, there's a one just got a similar part of DZone article published on this records a couple of days back. I think. Yeah, that's all from me, and I hope that I believe that records are going to be used very frequently once the Java 17 gets which is the LTS version, which gets up to, which gets more popular. And that's all from my side, unless you have any further questions. Thank you. Sure, Yog. I know you'll have a question. Can you use the mic? Or yeah.
When you started to type the record, the record itself was not shown as identifier or as keyword. The color was unlike the keyword. Yeah. But now, when you end it, it was colored like a keyword. Why?
Let's see. So you found out a bug, I think. Yeah. It's record here has to be shown as a colored one. If it is not, it's a bug. But record here would not be shown as a. So. I'm not sharing, right? So I think I should stop sharing this and. Right. So what I was telling was record here should have been colored. If not, it's a bug. Maybe there is the callback is not proper there. But record here in the identifier definitely would not be shown as a colored one. So. Yeah.
Just a side note, if you use record as variable name, you get a SonarQube warning. It's a rule-based checker. They not suggest to use record as variable name.
It's not. Yeah. That's a programming practice. I'm saying somebody wants to really. I would not use it, but somebody really want to use it. Yeah. But you know that it's I'm sure you know that, like I was mentioning during this thing, it's not an easy thing for a compiler for us, which is based on a context-free grammar, to figure out whether it's a keyword or not, restricted and if it's not. So we stop parsing a record, then we go spawn a Vanguard parser, check whether it compiles, and then say, okay, it's a restricted identifier, or it's a this one. Yeah, sure. So, I think that's.
In your pattern matching example, there was something like case point x,
yes.
y.
Yeah.
I didn't really understand what that means. Can you explain that a little more?
Sure. Suppose suppose I have a record which is a point, and it has two coordinates, x and y. Just hold on to that, and then So this is, you have a record point int x, int y. Then I have a switch statement. This is the new pattern switches which have come in, where you can switch based on the type. So far we have been switching based on only on the value, right? Switch, if it's an integer, switch I, case 0, case 1, case 2. So these are kind of constants which you switch. But this is pattern switches which has come in lately. It's still in the 4th preview for Java 20. It's still not standardized. And we would be, you can try it out in Java 19, but it's still in the process of development. You can have case integer I, for example. Or if you have used the...
Okay, so this checks if object O is an instant of this record.
Yeah, something equivalent. Yeah, that's what. So this is what. And not only that, it extracts, you can extract the X and Y out of it. So that's the pattern which would be used with records. Thank you. I think it can be U and V. I don't know, but it can be anything. Yeah. Because at some point you would have underscore coming in. Say, I don't care, right? So. Sure, okay.
In this case, if I also want to access the point P as a variable P, can I have both? Or instance of point X, Y, bracket P?
Yes, you can. You can use this. You can extract P, you can extract X, you can extract Y.
Okay, thanks.
Okay. Okay, I guess that's all. Oh, okay.
From the bytecode you showed, it seems that the records are full-blown classes in a way. So from that I understand that they're not really, say, a compact structure. So they could be used for, say, more performant computation of, say, complex numbers, so to show them as numbers, or when I want to really have points with low overhead, that's not really a replacement when I want to have a large number of points used by records.
I did not get that question.
Maybe I was mumbling too much.
No.
So the point which you show there is like a regular class, which is a little bit bigger than when I would have something like a struct in C.
Yeah.
So when I want to have a lot of points because I want to do some calculation, or I want to have something like a representation for complex numbers, I would still have the overhead of classes. So it's only boilerplate, which is done by the compiler. So it's not really a compact structure, which I get out of a record.
Yes, it's going to be a boilerplate by the compiler, but when you use it along with switch patterns, you probably will find it useful because you can have specific cases. Say you want to have a point with a particular number, catch a few numbers, and then at a later point of time do a catch all of all the points, all the imaginary numbers. You can do that, but from the compactness point of view, yeah, I think you're right. Or Stefan, you want to add something?
To know if there will be possibility to combine records with value classes.
Yeah, that might address that, right? But value classes are, we don't know when we'll.
Project Valhalla.
Yeah.
They will.
Yeah. It's for their meetings only. No, sorry.
They will provide capable.
If and when they will arrive in Java, are actually geared for compact representation and memory. So the slogan is it's coded like a class, it works like an int. So you can have compact arrays of these things, and I just don't know if there will be a combination of records and value types, but currently it's orthogonal to each other. So this is just for the source code view, and value types will be for the runtime view of it.
Okay, so. Yeah.
In this example, why do I have to say point int x? Why do I have to mention the type? Isn't this already clear from the record?
Good point. But if there are multiple...
Yeah, so here's instance of point int x. Can I just write instance of point x and y?
Well, good question. Okay. So I don't remember it offhand. Why? I think this is also fine. Yeah. Yeah. Okay. I think. So if you have further questions, just catch me or Stefan or any of the team outside. Thank you. Thank you.